If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in GATE Power System series. So today again we will be solving 5 questions starting from question number 171 to up to 175. Okay, then let's try to solve these questions. In question number 171, resistance switching is normally employed in. So resistance switching is something of this fashion, what we have done here. So it gives an alternative path to your that arc. There during arc extension there is a arc continuously forming between these two contacts which are opening. So it gives an alternating path for the current to go to that path so that this arc can be extinguished. And this is not required for all breakers. Basically, if you see minimum oil circuit breakers, here already oil serves as a purpose of resistance. So air blast circuit breaker, in air blast circuit breaker what happens if we give air blast, that is we give forcible air to take out this charge particle from this from the spacing between the two terminals which are going to be open. So when you take out this charge particle, so you need to give an alternating path for the current so that that transition can happen, and this alternating path is given through the resistance, which is a very high value, so that that current comes down to a very small negligible value and finally the arc is quenched. So that is known as your resistance switching, so which is given for your D, that is air blast circuit breaker. You remember this one, which one is applicable for which one. Now 172, the interrupting time of a circuit breaker is the period, the instant of. So circuit breaker period. So what is the operating type of circuit breaker? When the circuit breaker get signal to initiate the process of opening and after the completion of opening, that should be the operation time of circuit breaker. So the energizing of the trip circuit, when the trip circuit is energized, that gives the signal to the circuit breaker to open. From that point to the arc extension of an opening, up to the extension of arc, the arc should be completely out of the scenario. So when the arc is completely extinguished, then we say the job is done, it is open now. So this is the operating time of circuit breaker. Because whenever there is a fault, first relay will sense it, then it will compare with its initial value. If it's over then threshold logic or whatever logic it is set up that relay, if satisfies that relay, then it will initiate signal to your trip circuit. Once the trip circuit got signal, from that onwards up to the extinction is the circuit breaker operating time. So the answer is option B. You can check this all these times circuit breaker operating time relay in the switchgear protection videos, where we have mentioned all this, where primary backup settings of the relays we have done. There you can see. A lightning stroke discharges an impulse current of 10 kA peak to a 400 kV transmission line having a surge impedance of this much. The magnitude of the transient overvoltage wave in either directions, assume equal distributions from the point of the lightning stroke will be. So whenever the current strikes in a transmission line, so suppose this is your transmission line, so current strikes here, so you see what is the surge impedance there. On the basis of that you convert it into over voltage, then you decide which voltage will go whatever side. So if it is a 10 kilo ampere, then it will be multiplied by, because 10 kilo ampere you are injecting and you have a resistance of that surge impedance of 250. So this is the voltage that it will generate, that is 2500 kilovolt. Okay, then there is a wave. Now you can say a wave of a volt sources of 2500 kV is suddenly applied to this junction. Now in either side, either you look from this side, whatever voltage wave it will propagate this side, so this will be same because they are of parallel notion. You can see from this side also whatever voltage it goes this side, they will be same. So it is a parallel notion. So either voltage if you see, so the lightning stroke will be 2500 kV. So if a lightning stroke is given in ampere format, first you convert it into voltage, multiplying it by the surge impedance of the line. So that much voltage source you connect to the transmission line, and then you think. So it is answer is 2500, that is C. Now if you come to 174, the keeping in view of cost and overall effectiveness, the following circuit breaker is the best switches for capacitor bank switching. Now capacitor bank switching is generally done to nullify the effect of the inductor. This we have seen, it can be connected in shunt or series. There are two applications. Series is directly compensating that axle, which increases the power transfer capability, and shunt is basically to give a voltage support. So this type of capacitor bank switching, because you need fast operation, so you will be using in that circuit breaker, which circuit breaker operates very fast, or where the dielectrics forms between the spacings should be very fast. that is either a vacuum or SF6. Both can be used for circuit breaker capacitive bank switching. But if you see the VU and the overall effectiveness, cost and VU overall effectiveness, then it is always vacuum, because SF6 is more costly. So your answer is option A. We will be using it where it is very fast operation, that is vacuum and SF6, but this is very costly. So 175. A 3-phase 33 kV oil circuit breaker is rated for this MVA 3 seconds. The symmetrical braking capacity. So braking capacity, it is easy. From here you can find the braking capacity. This and 33 kV. From that you can, MVA is given, this much given. So what should be the braking capacity? So it is always 2000 into 10 to the power 6 divided by root 3 into 33 kV. So this is its braking capacity. If you do this one, I think you will get 35 kiloampere. So this much is the braking capacity. Okay. So if this is braking capacity, then that is your answer, option C. But if they ask you what is the making capacity, then making capacity is always 2.55 times of the braking capacity. Or you also remember this one. If they ask you what is the symmetrical making capacity, that will be 2.5 times the 55 times of the braking capacity. Remember this one. If you like the video, then press the like button and please give your valuable comments in the comment section.